When we think of men of science, the name of Aristotle is one of the earliest names that comes to mind. True, he is usually known as a philosopher, but in his time, philosophy included many of the studies we call sciences today. We know him through the many books he wrote, which have influenced Western thought for more than 23 centuries. These books represent virtually all that men knew of science in Aristotle's time. When they were originally written, about 23 centuries ago, science was a new kind of learning. And the man who helped to shape this new learning was Aristotle, one of the greatest thinkers of all time. We can appreciate his work in science, for example, when we realize that earlier peoples, before the Greeks, had little or no science. True, early peoples had developed systems of measurement. They had invented number systems and methods of writing. They had learned to preserve their knowledge and to put it to use. They were craftsmen and builders, but they were not scientists. Early peoples learned to do useful things without understanding principles. They knew how, but didn't know why. They could observe changes in seasons. They did not understand natural phenomena. It remained for the people of ancient Greece to ask why. Argument and discussion were part of their everyday life. They loved to philosophize, to reason about why things happened. They turned eagerly to their learned men, their thinkers, for answers to their endless questions. Out of such speculation, the Greek philosophers, or lovers of wisdom, developed orderly systems of knowledge. Building on the knowledge of earlier peoples, the Greek made great advances in seeking answers to a basic problem. What is the nature of the universe? The Greek thinker Pythagoras believed that mathematics was the key to understanding the universe. He and his followers developed important theories that helped lay the foundation of geometry. In a broader sense, they felt that all nature was written in mathematics. The philosopher Democritus propounded a materialistic theory of the nature of the universe. Today, his idea astounds us with its accuracy. Democritus held that all matter was composed of atoms, which he defined as tiny, invisible particles that were in constant motion. This was the first concept of the atomic theory of matter. Not all the Greek thinkers were theorists. Hippocrates was a physician and a practical investigator. Hippocrates and other early men of medicine gained knowledge about the human body by actual observation. Plato, perhaps the greatest of Athenian teachers, believed that men could answer questions about themselves and the physical world by reason alone. Plato taught that the senses were not important in investigating the material world. This idea was contrary to experimental science, the kind of science propounded by Plato's most famous pupil, Aristotle. Aristotle believed and taught that facts must be the basis of reason. In this idea, he came closer than earlier Greeks had in developing a scientific method. Like other great thinkers of Greece, Aristotle had his own following of students. In about 334 B.C., in Athens, he had opened his own school called the Lyceum. Here, young men could learn from him and his associates practically everything that was known in their own day, for not much was known. They learned from Aristotle's library, where he had collected a treasury of the learning of earlier men. They learned from his lectures and demonstrations. Always he stressed the method of study he'd developed, the beginnings of a scientific method. based on the collection and evaluation of data. You must study facts, he told them. It is in facts that we must seek general principles. His followers learned that it was important to observe, to experiment, to assemble new facts. To get his facts, Aristotle most likely worked with equipment that was quite primitive by our standards. Scalpels and probes of early physicians were known to him, as were crude devices to measure weight, time, and size of angles. Yet, in a larger sense, his laboratory was the world about him. For example, a flower might be a specimen to illustrate the importance of a man's senses. To see, to touch, to observe and examine any subject, and then to describe it in accurate detail. This would help obtain the facts. In studying plants and animals, Aristotle saw them perhaps more keenly than anyone before him. He observed animals close at hand, particularly sea creatures, and described accurately the characteristics of many species. He was among the earliest to dissect animals and to study anatomy. By dissecting, he and his followers learned something of the complex structure of living things. For instance, he noticed similarities in animal structure. By carefully studying and comparing such similarities, he concluded that similarly structured animals could be classified in groups. Thus, lobsters, crabs, and crayfish, though differing in outward appearance, belonged in the same classification. He found that some animals have red blood, others do not. He thought this separated animals into two large divisions. This was the forerunner of our modern organization of animals into vertebrates and invertebrates. He defined man as an animal, as a rational animal. He also arranged his classification by structure, proceeding from the simplest animals he knew to the most complex, man. This he called a ladder of nature, but he didn't seem to think of the idea of evolution. He applied his scientific method to the study of the embryonic development of animals. He described how the embryo of the chick could be studied by opening eggs that had been incubated. Watching the development of chick embryos, he concluded that the human infant developed in somewhat the same way. In all natural objects, he said, there is some marvel. And many were the marvels he investigated. He studied bees and carefully described their habits. He wrote about the reproduction and the rearing of the young of many kinds of animals. With equal interest, he inquired into the physical sciences. He described the principle of the lever, and he argued that the heavenly bodies, including the earth, were round. He described such things as meteors and wrote explanations of the phenomena of weather, which were the forerunner of the science of meteorology. Aristotle collected his information with the help of his students and others. For instance, old written records, rare plants, and strange birds were sent from the Orient by Alexander the Great, a former pupil of the great teacher. All these things were information to Aristotle, data that he could evaluate. Anyone with information for him was welcome, whether it be a learned scholar or an ordinary man. Aristotle realized that information from untrained observers could be wrong. But he felt he must not overlook anything that would further his investigations. The world was his laboratory, and he continually sought to understand it. His observations and teaching were part of Aristotle's greater goal, recording all the knowledge of his day. He hoped his books would be a foundation for later generations to build upon. Probably he never dreamed what a long-lasting influence his work would have. His writings were copied and recopied for centuries. Unfortunately, his errors, too, were perpetuated. It was not until the Renaissance that some of Aristotle's teachings were challenged and proved wrong. Yet today, 23 centuries after Aristotle, we still owe much to the Greek thinker. The scientist today is still trying to expand man's knowledge by using the several steps of the scientific method that Aristotle first attempted. The first of those steps is the identification of the problem. In solving the problem, the data collected by earlier scientists must be reviewed. New data may be collected by making observations and by devising experiments. Collecting data is the second step in the scientific method. Formulating a theory or hypothesis to explain the results is the third step. Testing the theory by further experimentation and practical application is the fourth step in the scientific method. The fifth step is drawing a conclusion. The hypothesis is confirmed, abandoned, or modified. This method, so vital to the development of science, had its beginning in the work of the great teacher, Aristotle. How shall we think of him as a scientist? In particular, we may think of him as the great man of natural science, whose investigations laid the foundations of botany and zoology. And we can remember that from his observation of specific facts, he arrived at generalizations or theories, the beginnings of the scientific method. At the same time, we must remember that he made mistakes. His instruments were crude, and his experiments were sometimes not thorough enough. For example, Aristotle believed that the Earth was at the center of the planetary system, and that the sun revolved about the Earth, an error that was to persist until the time of Copernicus. Yet, for all his faults, Aristotle advanced man's knowledge. He said, "I found no basis prepared, no models to copy. Mine is the first step. Though worked out with much thought and hard labor, it must be looked at as a first step and judged with indulgence."